Good morning, dear students. Welcome back to RV online classes. Today I am going to start for 6th class mathematics, that is whole numbers, chapter 2nd. Whole numbers. After this chapter, I will explain first chapter. So, students, here you know that in previous class we learned natural numbers, what are natural numbers? Natural numbers, counting numbers are called natural numbers. Counting number, which are those? 1, 2, 3, 4, 5, so on. This is natural number. Counting numbers are called natural numbers. Counting numbers are called natural numbers. What are counting numbers? Counting numbers 1, 2, 3, 4, so on up to infinity. This is counting. These are counting numbers 1, 2, 3, 4, and so on. Counting numbers are called natural numbers. Now, the natural number is denoted by capital N. The natural number is denoted by capital N, and the set of natural numbers are 1, 2, 3, and so on. So this is the set of natural number. Natural numbers, counting numbers are called natural numbers, and the set of natural number is denoted by capital N, and the set of natural number is 1, 2, 3, and so on. Here, friends, the smallest number is 1. So the smallest natural number is 1. Therefore, the smallest natural number is 1. Hope you understood. Next comes to whole number. Whole numbers. Our second chapter is whole numbers. So what are whole numbers? Natural numbers with 0. Natural numbers with 0 is whole number. Natural number is 1, 2, 3, 4. These are natural numbers. Here with 0. See here with 0. Natural numbers with 0 is whole number. So here this is a 0. 0, 1, 2, 3, and so on. This is whole numbers. So whole number is starting from 0, 1, 2, and so on. Here the whole number is denoted by capital W, and the set of whole number is 1, 0, 1, 2, 3, and so on. This is a set of whole number. The set of whole number is denoted by capital W and start from 0, 1, 2, 3, and so on up to infinity. Here, which is the smallest whole number? Therefore, 0 is the smallest whole number. Here, 0 is smallest whole number. Understood? See students, for example, 2, 3, 4. This is our number 2, 3, 4, and this is also whole number. The set of numbers, see here, 2, 3, 4, 5, 6, 7, 0, 1, 1000, 10,000. These are whole numbers. Understood? Next thing. Our next topic is predecessors or successor. Predecessors and successor. Predecessors and successor. Predecessors and successor. Predecessor is nothing but previous number or before. For example, take smallest number 6. This is the smallest number 6, and the predecessor of 6 is already you know that. Predecessor means previous or before number, before one number. Predecessor of 6 is 5. Predecessor of 6 is 5. Or see here, this is 6. You should subtract 1 in 6. Predecessor means minus 1 or before a number. 6 minus 1 is 5. So the predecessor of 6 is 5. Understood? Next, successor. Successor after number, after one number. See here, for example, 7. The successor of 7 is 8. You should add here one number. You should add here. Successor means after number, and predecessor previous number, that is before, that is 5. The predecessor of 6 is 5 and the successor of 7 is 8. Understood? Next thing, take another example. See here, 20981. This is a 20,981. This is our number, and the predecessor of 20,981 is here. What should we do here? Subtract 1, because we are seeing here predecessor of this number. See students, 1 minus 1 is 0, and keep as it is all numbers 8, 9, 0 and 2. The predecessor of 20,981 is 20,980. Understood? Next, the successor of another numbers, 9,999. 9,999. The successor of 9,999 is, see here, we should add 1. Successor means after 9,999. See here, 9 plus 1 is 10, 1 carry. 9 plus 1 is 10, 1 carry. 9 plus 1 is 10, 1 carry. And 9 plus 1 is 10. Here, the successor of 9,999 is 10,000. Understood? Next thing. Next comes to our next topic, that is number line. Our next topic is number line. What is number line? The name itself indicates number line. The name itself indicates the numbers on a line. This is a line and the numbers lies on this line. There are three parts. Center 0. To the right, at an equidistance, there are positive numbers 1, 2, 3, 4 and so on. To the left, similarly, to the left, there are negative numbers -1, -2, -3, -4. All positive numbers or positive integers, and to the left or negative integers or negative numbers. This is your number line. See here, once again I will explain number line. The name itself indicates the numbers on a line on the line. Center 0 and to the left, sorry, to the right all positive numbers and to the left all negative numbers. Understood? Next thing. Addition on a number line. Addition on a number line. Addition on a number line. See students, here we will see how to add numbers on a number line. First example, 3 plus 2. Take small numbers. 3 plus 2. We know that 3 plus 2 is 5. But on a number line, we will see here 0. If you want to extend, you can, but we don't want here negative signs because two integers also, two numbers also in positive. So from 0, take at equidistance. Here 1, 2, 3, 4, 5, 6, 7. Why we are not writing their sign? Because any number, whatever the numbers does not have sign. If the number not have sign, it indicates that it is positive number. See, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. So on. Okay? Here, the thing is, we should add on a number line. 3 plus 2. 3. First number is 3. So, we will start from here. From 3, we go to 2 steps. 1 and 2. We know that 3 plus 2 is 5. Now, we are adding here on a number line. So these two numbers are positive numbers. So we are taking here right side of the number line. We are adding. See here 3 plus 2. We will start from 3 and goes to 2 steps. One step on 4 and another step 5. The answer is plus 5. 3 plus 2 is 5. Understood? Next. Subtraction on the number line. Subtraction on number line. Take one example. 6 minus 4. 6 minus 4. See here. This is a number line. We are starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Here the question is 6 minus 4. 6 minus 4 is 2. You already know that. We are seeing on a number line. From 6, see here, we are subtracting here. We are taking right to the left side because we are subtracting. See here, 6. From 6, we are going to 4 step back. 1, 2, 3, and 4. The answer is 2. We know it. The answer is 2. 6 minus 4 is 2. Understood? Next thing, multiplication on a number line. The third one is multiplication on a number line. Multiplication on a number line. See here, 4 into 2. 4 2s are. See on a number line. 0, 1, 2, 3, 4, 5, 6, 7, 8. 4. See here, start from here. 4. 2s are. 4 2s are. Here 2 times. So we are taking here 2 times. 4 2s are 4 1 time and 2 times. 2 numbers and 2 times. We are leaving these 2 numbers and we are multiplying 2 times. 4 1 2. 4 2s are 8. This is a multiplication. See here on multiplication we are multiplying 4 2 times. 4 into 2, sorry, not 2 times. Here 4 into 2. We are starting from 4, leaving 1 and 2 steps. 2 steps. 1 step and 2 steps. 4 2s are 8. The answer is 8. Next, dear students, our next topic is properties of whole numbers. Properties of whole numbers. Properties of whole numbers. Here there are three or four types of properties. First one is closure property. In closure property, see, let's say two whole numbers a plus b. These are two whole numbers. A plus b is equals to c. See here, we are adding here two whole numbers. We will get c also whole number. Let's see one example. 2 plus 3 equals to how much, dear students? 2 plus 3 equals to 5. 2 is also whole number. 3 is also whole number. And 5 is also whole number. In closure property, we are taking 3 whole numbers. If we add 2 whole numbers, we will get third one also whole numbers. In addition, 2 plus 3, these are two whole numbers. And we are adding these two whole numbers, we will get third one also whole numbers. 2 plus 3 is 5. This 5 also whole number. Let's see, in multiplication, A into B equals to C. A into B equals to C. This A, B and C are whole numbers. Dear students, take one another example. 5 into 10. 5 into 10 is, yes, 50. 5 tens are 50. 5 is also whole number, 10 is also whole number, and 50 is also whole number. So here, in addition and multiplication, this property applies. Let's see, in division and subtraction. In division and subtraction, let's take one example of subtraction. See here, 6 minus 4. 6 minus 4 is 2. This is also whole number, and this is also whole number, and this is also whole number. But in some cases, for example, we are subtracting 6 from 4. 4 minus 6 is minus 2. This is not a whole numbers. Minus 2 is not a whole numbers. So, 4 minus 6 is minus 2. 4 minus 6 is minus 2. This is not a whole number. Dear students, it only applies in addition and multiplication, not in subtraction and division. Let's see division. Let's see an example of division. See here, 6 divided by 0. This is division. 6 divided by 0. It is not defined or infinity. So this is not a whole number. Understood? This is not a whole number. So it only for addition and multiplication, the closure property is satisfied. Next property is commutative property. Next one is commutative property. See here, what is commutative property? This is nothing but A plus B equals to B plus A. Commutative property, A plus B is equals to B plus A. Take an example, 5 plus 6. 5 plus 6 equals to 6 plus 5. Here A is 5 and B is 6. So A is 5 and B is 6. 5 plus 6 is 11 and 6 plus 5 is B plus A also same. 6 plus 5 is also 11. So here they are equals. So A plus B is equals to B plus A. Similarly, A into B equals to, in multiplication, A into B equals to B into A. Take one example, 3 into 5 equals to 5 into 3. 3 5s are here, A is 3 and B is 5. 3 5s are 15 equals to 5 3s are 15. This is also equal. So in commutative property also, in addition and multiplication it's satisfied, and in division and subtraction, yes. Let's see an example. 2 minus 6 minus 4. It not comes. Sorry. Next property, associative property. Next property is associative property. Next property is associative property. Here in associative property, A plus B plus C equals to A plus B plus C. These three are whole numbers. Take whole numbers example. 2 plus 3 plus 4 equals to 2 plus 3 plus 4. See here, 2 keep as it is plus 3 plus 4 is 7. Next, 2 plus 3 is 5. 5 plus 4, sorry, 5 plus 4 keep as it is. 7 plus 2 is 9 and 5 plus 4 is 9. So, associative property of addition A plus B plus C equals to A plus B plus C. Similarly, in multiplication, see here A into B into C equals to A into B into C. Next, here 4 into 5 into 2. Here A is 4, B is 5 and C is 2. Take A is 4 into B is 5 and C is 2. Now multiply. Keep 4 as it is. 5 2 is 10. 4 5 is 20 into 2. Now multiply 4 times are 40 equals to 22 is 40. So associative property under addition and under multiplication. Next, the last property is distributive property. The last property is distributive property. Last one is distributive property. Distributive property under addition. See here. A into B plus C. See here. This is distributive property. How we will distribute here? See here. First number with first. A into B plus, keep as it is, A into C. First number with first and second number with first number with last one. First with first and first with last. A into C. Let's take here an example. 2 into 3 plus 4. 2 keep as it is. First solve this bracket. 3 plus 4 is 7. 3 plus 4 is 7. Now multiply these two. 2 sevens are 40. See? Now here A is, see here, A is 2, B is 3 and C is 4. A is 2 into B is 3. Keep plus as it is. Next, A is 2 and C is 5. Yes. Sorry, 4. 2 3s are 6 plus 4 2s are 8. Here, 6 plus 8 is 14. So this is distributive property under addition. A into B plus C equals to A into B plus A into C. Let's see an example. Another example of this distributive property. This is the smallest numbers we will get easily if you take biggest numbers. See here, multiply two biggest numbers, 728 into 101, 101. We are multiplying like this, 728 into 101. 1 8 8, so on. Here we will apply distributive property. We will get easily the answer. See here, what is distributive property? A into P plus C. This is distributive property. See here, split 728, keep as it is. 728. Split 101 as 100 plus 1. 100 plus 1 is also 101. So here 728, A is 728 and B is 100. Here C is 1. See here, this is B and this one is C. We are splitting 101 as 100 plus 1. Now here B is 100 plus C is 1. Now apply here distributive property. A into B plus B into C. Now A is 728 into B is 100 plus B is, sorry, A into B, A into C. A into B plus B into C. A is 728 into B is 100 plus A is 728 and C is 1. Now solve this 2 and this 2. 728 into 100 is, we know that 728 ones are 728 double 0. 728 ones are 728, keep double 0 as it is. Now here 728 ones are 728. Now add this 8 plus 0. I will simplify here. 728 double 0 plus 728. 0 plus add here. 0 plus 8 is 8. 0 plus 2 is 2. 8 plus 7 is 15. 2 plus 1 is 3. 7 as it is. 0 plus 8 is 8. 0 plus 2 is 2. 8 plus 7 is 15. 1 carry. 3 and 7 as it is. So answer is 73,528. We will solve same by applying distributive property. Let's revise. First thing is whole numbers. First one is natural numbers. What are natural numbers? Natural numbers are, counting numbers are called natural numbers. 1, 2, 3 and so on. Natural numbers. Next, natural number is denoted by capital N and the smallest natural number is 1. Next, whole numbers. Whole numbers, our second chapter is whole numbers. Natural numbers with 0. Counting numbers with 0 also and natural numbers with 0 also. Same. The definition is same. So, whole number is 0, 1, 2, 3 and so on. This is whole number. The whole number is denoted by capital W and the smallest whole number is 0. The smallest whole number is 0. And we saw in this chapter, we learned addition on number line, subtraction on number line, multiplication on number line, and whole numbers property. In the whole numbers property, there are 4 properties: closure property, commutative property, associative property, and last one is distributive property. We saw some examples. Hope you understood, students, and I will continue in next class. Thank you.